All right, let's get started. Make sure stream's up and running. Test that the audio is good. Do that by here. Looking good so far. And do we actually have viewers at this moment? According to we do. See if we can find anything. Okay. Gonna wait a few more minutes before we get started. Just let people trickle in. 7 o'clock right now. Ooh, I should turn that off. Oh, neat, that's working. Awesome. We have the chat messages showing up on the stream. That's neat. Hello, Zly4. Thank you for joining in. Is it showing you as a mod? Weird. No? Hello, Jason. Welcome to this weird review that I'm doing. I haven't done anything like this before, but hopefully it works well. Hello, Grace. Welcome to the stream. I'm just going to wait one more minute and we'll get started. A lot of people have already emailed me saying that they're not available at this time, and they've requested a recording of this be available either through YouTube or something else. All right. Let's get started. Welcome everybody to my Twitch channel. I should turn off these notifications. Sorry. No idea how to turn them. Really annoying. On quiet hours. Don't know what that means. Okay. Well, hello, Moel Deep. Hello, everyone. Welcome to the Java Games Programming Java Concepts Review. I'm Zen, your host. I'm guessing most people joining us right now are from CPSC 233 midterm review. I'm incorporating this with my other with the other projects that I have, namely Java Games Programming, because this is Twitch and we do need to abide by their rules. So this is kind of a themed toward Java Games Programming. but we will cover the concept that we really need to. So based on the emails that I've received and the discussions I've had on the board, these are the concepts that have been requested. So starting off with copy constructors, including inheritance, and then doing a trace of how those copy constructors work, method overloading and overriding. There are polymorphism, privacy leaks, method call tracing, and there was a request of GUI, but this is a very broad concept, so I'm not sure what in particular about GUI that needs to be covered. If nothing comes up, then I'm going to skip over GUI, but if something specific comes up, then I might be able to get into that. I'll give you a fair warning. GUI is my least favorite topic. It's the one I'm most weakest on because I haven't used it in a long time. All right, so getting started with copy constructors. As I mentioned, we're going to do a bit of a themed games programming theme. So let's start us off with giving a class. Those of you who are in the Tuesday, Thursday tutorials know I've been using some kind of like RPG game themed items. So I use like swords, staffs, weapons, these kind of things. So let us use the same example again. So public class sword. Going to make the code just a bit bigger. Let's see, zoom, Control+. Is the code good for people to see? Is this clear enough? All right. Then we're going to give it a few instance variables. Private. And let's give it a crit rating. Give it a Boolean one-handed. Is it one-handed or two-handed? All right, so it's good. I just wanted to give another heads up that there is a bit of a delay between me actually speaking here and then what you guys are seeing on the stream. If I'm waiting for responses, it'll take a few seconds. Is this the new Zelda game? Unfortunately, no. Not Zelda. Okay. All right, where were we? Okay, yes, so we have our sword, which has a crit rating. Has a Boolean if it's one-handed or two-handed. Let's give it a name. And a damage value. And now we will work with our regular constructor, so let's just go with the default. Public sword. And the way we would do it is assign it default values. So by default, there is no crit. It is one-handed. Name. I'll leave this blank. I'll let you guys suggest something. If I can get a suggestion for a name, I'll add it here. And damage equals. Oh. Here we go. We have our trusted D20. I'm just going to roll 1. And damage is 19. That's default damage. I could name it Jason Lee and name it or 60. I'm not going to make it do damage, but I will name it Jason Lee. How's that? Ooh, Ultima Blade. Those are all good names. For the interest in time, I would just make these decisions quickly. Okay. And then we can give it a 4-value constructor. So int crit, Boolean one-handed, string name, int damage. Assign these values. Now what we're doing here is the audio has awkward jumps. That's really odd because that really hasn't happened to me before. Is it still understandable, or is it too much of an issue? And while we wait for the responses there, I'll go on with saying that this is where we're repeating a bunch of code. We're assigning values to our instance variable here. So we can actually just make a simple call to our for value constructor. We can just do sort, and we can pass in these values: 0, true, 20, and 19. Now we can just have this. Audio is perfectly fine for Mr. Scrufflepuff. Okay. Oh, it's the noise gates. Okay. Unfortunately, they have to exist because you get a lot of background noise if I don't have that. And I've tried a lot of possibilities, and this is the best one I have so far. Oh, I do need to assign value to damage. Yes, thank you. This.damage equals damage. And then we also have the copy constructor. Public sort. Call it other. And the way we're going to do this is, once again, we're going to go over our for value constructor and just passing in these values: other.crit, other.one-handed, other.name, and other.damage. Now, how long is this session? Yes, it's about an hour, but depending on how many people are here and how much we are covering, I'm okay with going longer. So it's up to you guys. Or if we get done early, then we can finish early. All right. So where was I? Yes. So using our copy constructor, we would just call our for value constructor and assign these values as normal. I'm going to save this and save it as my normal. So where did we go? CPSC233, review, sort.java. Now what I'm going to do in this is, okay, so we have a question, is what does this other do? So what this other does is we are creating a copy constructor. So what we want to do is we have this other sword, and we want to copy, rather just make a copy of it. And that's the purpose of it. So we are copying its crit value, its one-handed value, its name, and the damage value. I'm not going to play Borderlands after this review session. I do have other work to do, unfortunately. Okay. So the way we're going to see how this is going to work is, let's create a main method. And here we're going to be creating two sorts. So one sort which goes to the default constructor, a second one which goes towards using the copy constructor. And to make sure how we find out what the trace is, we're just going to put in print messages here. So I'm going to call it just the method signature. So just sort. Now, if you took a look at this week's review exercise, or practice exercise we had, this is similar to what I did there. Print, create. Okay, would I post this review on your channel? Yes, so this review is being recorded. After it finishes, it's available on the channel. I'll also post a copy of it on YouTube. And then I'll post a link to it on our discussion board. Okay, so coming back to this, what we were doing here is we create a first sort, which is using the default constructor, and then we create a second sort using our copy constructor. And using these print messages here, we'll be able to see what the trace is. The way it'll work is for the default constructor, it'll call this particular constructor. It'll jump to this line of code, which is our 4-value constructor. So it comes down here. It's going to assign these values. It's going to print this statement. And then it's going to jump back to the constructor that called it. So it'll go jump back here. And then it'll print this line. And then it's going to jump back to whomever called this code, which would be right here. And then it'll move on. Now, purposely, I missed one thing here. And that was when we actually get to this particular line, there is an implicit constructor called, and I believe it's something like this. It's the generic object constructor. Where do you find the practice? It's on D2L, week 10. Yep, the one and only. Awesome. Thank you, Most Basic. So, continue. Command prompt. Is the text on command prompt viewable to other people? All right, let's take a look. We have a few errors. Now, if you guys haven't gotten this far yet, or rather haven't understood what these errors means, these are really, telling us what's going on. This tells us the file name, and this tells us the line number. And here it's describing what's wrong. So it cannot find the symbol sword on line 8. So let's go up to line 8. This is our call to the 4-value constructor. And do we have a spelling mistake? SWORD? Nope. Int boolean string int. What are we missing here? This cannot find the symbol sword. All right, can anyone help me out here? What are we missing here? Okay. Int boolean string int. Use the word this instead of sword. Awesome. Thank you. And which means the same would apply here. So we go back to our command prompt, compile it. Awesome, it compiles. So here we have now creating the first sword. So this line of code. After here, we jump up here to the default constructor, which jumps down to the 4-value constructor, and then it prints its signature. Somewhere I can see. Prints the signature here, and then it prints the signature of the default constructor. And then we create the second sword. It goes down to our copy constructor, where the first line is make it jump to the 4-value constructor, assigns the values, makes the print statement, jumps back to the copy constructor, and then prints out its signature. And here we have, what do we call it? Constructors with the trace. Any questions regarding this? And while I wait, I'll move on to inheritance. I had a request earlier. This dot name equal, what was the name? Name equals Billy. All right. Are these codes going to be posted as well? Yes, these files will also be posted. All right. Okay, so I'm going to assume there was no questions on the trace for the sort.java. Solid damage, yes, that was one of the recommendations from the when I was creating sort.java. Now we're actually going to do a bit of inheritance. We're going to make sword extend our weapon class, which means we don't really need the name and damage here. Damage. Oh, we have Bob the Cool Man. Welcome, Bob. I was using a D20 for damage, but someone recommended that particular number. Okay. So what we want to do is assign the name and damage using the super constructor. So we do super. And then the 2-value constructor here, making sure our variables are ordered properly. So we have the int damage, then the string name. Normally you want to have it in similar order, so it would be damage first, then name. But we're doing this fast. So we do this. And the other ones remain the same. So we can, once again, put our messages here. And then we can do now if we, without changing anything else here, go back to our command prompt, file. We did something else here. Let's see. Okay. So the issue we're having is these other.name and other.damage doesn't belong in the sort class, so we need some way to get it. We can add our public and trusty getters. And then instead of using directly, you can do get name and get damage. So this is actually going to change our call stack a little bit. Gotta put my messages here as well. One difference that you guys might be seeing is in the constructors, I'm putting these messages for the trace at the bottom, but for non-constructor methods, I'm putting it at the top. And that's because when you're using a constructor, the first line must be either using a this or a super. And if you don't add it, it gets added implicitly. So we do need to add it. That's why I'm putting it at the bottom. The print statement at the bottom. Okay. Now what's going to happen is our call stack is going to change a bit when we actually do this, because these two parts here, they're actually calling these get name and get damage method. So we save it. Let's see if we can compile without errors this time. We can. Awesome. We run it. Now here we see create sword, second sword, so we get the get name, we get the get damage method, we get the 2-value constructor in our weapon class, then we get the 4-value constructor in our sword class, and then our copy constructor in our sword class. Okay. And here we have constructor call trace using including inheritance and copy constructors. Do we have any questions so far? Or should I move on to the next topic? Is it possible to make the command CMD text bigger? I think so. Edit properties. There we go. Anything is possible as long as you believe. That is true. All right, so should I move on to the next topic, or do we want to continue on with constructors and call tracing or method tracing? Greetings, Spider. All right, I'm not seeing any questions here. Next topic. So let's go here. Method overloading and overriding. Okay. This is something I always get these two terms mixed up. Let me just confirm myself. They're slightly different, but okay. Can we do another example with method tracing? So we will come back to method tracing. This one we did was particularly constructor tracing. So we will come back to method tracing. So let's move on with method overloading. The method overloading allows us to create multiple methods with the same name. However, they differ in how the arguments are provided to them. So let's say we have a simple method, so public void do damage with 0 values. And this is going to, we can test this method by a simple print statement, system.out.println. Do damage for whatever our damage value is. And then we can do another method which has the same name. Now, if you know Java, you create something like this, it's going to be really, it's going to give you a error message. Just to show you, I'm gonna need to change this message up a bit. So I'm just gonna say attack here. If I go back to compile this, it says the method do damage is already defined, so it can't really do create two methods of the same name. Method overloading allows us to do this. However, the difference between these two methods is the number of the arguments provided to them. So if we do this, and so we have two methods with the same name, but the second one has an argument. Now they can behave differently. So we have these. Test an example. So let's do sword.do damage, and sword.do damage with some value 5. So what's going to happen is when we actually call this method sword.do damage, we execute this method, and it's going to print do damage for whatever our damage value is. And then when we do the second one, while providing an integer, it's going to call this method because the signature matches, and it's going to call this print statement. Does the return type counts towards the signature? It counts towards the signature, but to be honest, I'm not exactly sure how it behaves with overloading. We can try that out though. It's not going to break anything. But first, let's do this example first. Compile again. What do I? Oh, damage is no longer part of sword. It's part of weapon. So I have to use the get damage method. And here we have do damage for 19, then attack. Okay, so now what we want to do is actually see if we can do this. If we have some the same name and same arguments, but a different return type. Hello. Now this is still going to give us an error because when we call this method, this particular line 36, Java doesn't know which method we're trying to call. It could be this one or this one, and that's because we don't know which. It cannot distinguish between the two. Scroll to the top. Okay. Are constructors a form of method overloading? Constructors are a form of method overloading, yes. And because we have, you can see a constructor as a method, a special type of method though. They have the same name, but the arguments are different. And the same thing's happening here. And I can show you that this should give us a compilation error because it says do damage is already defined. Now, a tricky question is if we actually have methods similar to this, or can overloading have different return types? We can try this out. Apparently it can. And the method works normally as before. I'm going to change this back to void. So that was method overloading. Fairly straightforward. Methods with the same name but different arguments, so they can behave differently. And then what exactly is the difference between method overloading and overriding? Perfect. That's what we're leading into. Method overriding comes in when we have inheritance going on. So as an example here, we have sword extends weapon. We have inheritance going on here. What we can do is the weapon class could have its own do damage method. So public void do damage. And what this is going to do is can do a print statement. Call it weapon does damage for so why does the get damage method needs to be called? It's because and the chat has answered the question already. It's because get the damage value is part of the weapon class and it's declared private. So the sword class, even though it inherits from weapon, it does not have access to the private members. Okay. So going back to overriding, we have weapon class, which has its do damage method. We have our sword class, which has its own do damage method. I'm going to comment this out for now, so that we don't get confusion with overloading as well. So we're just doing overriding so far. So we have two methods with the same signature essentially, because they return void. They have the name do damage and they have no arguments. This is in sword. And then in our weapons.java, we have, again, public void do damage, no arguments. But they behave differently because they have different output messages, different print line messages. Get rid of, comment this out here. So if I do sword.do damage, which method is going to be invoked? Is it this one, do damage for whatever, or is it the one in the weapons class, weapon does damage for whatever the number is there? And I wish I had the coin system implemented in this chat so far, so that we could have actually bet on what the response was going to be. Fortunately, I don't. We have vote for the second one, so that would be in the weapons class. Okay. So now take a look. We have sword equals new sword. Okay, so we have two votes for the one in weapon class. I was thinking the other way. I could be wrong. Okay. Let's try it out. It's not going to break anything. Compile it. Compile's awesome. Okay, and running it, we get the message do damage for 19, which is the one in here within our sword class. That's because our what happened here? Our object named sword with the lowercase s is of type sword. Now, if we were to do something like this, and I believe I would have to comment out this one. So we have weapon sword equals new sword. Now, if you were to execute this call, which method would get called? The first one in our sword.java or the second one in our weapon.java? With the will the midterm do damage? If you don't study for it, it might do damage on your grades. I mean, you can think of your GPA as your remaining HP, and then see how much it does for your how much damage the midterm does. All right, so let's compile again. Run it. We get do damage for 19. And that's because initially or internally, our object is still of type sword. Now, once again, if you were to change things a bit more, so our sword is fully of class weapon type. It's just the variable is named sword. That's it. Then which method would be called when we do sword.do damage. And just to show that we can actually do this, that's because our weapon class is not declared abstract. It's a concrete class. So our object here is of type weapon. And so when we call that particular method, we'll get the call from the weapon class. And you have evidence right here. Weapon does damage for number. And that's where we have method overriding. Okay. Is that good? Do we have any questions regarding method overriding, or should I move on? So the inherited class causes the method overriding. Yes. Our example, our sword.java, which is this class right here, when it creates its own do damage method, it's doing the overriding, because what it does, it's overriding the method in weapons.java, which is right here. Okay. Since I'm not getting any more questions, nope, there is a question. So it will call the method from class while the object is declared to as specified. Yes. If we have it so that our sword class does not have a do damage method, and we actually have a sword type object, it will call the method from our weapons class. But if it does, if our swords class does have this method do damage, and it is doing the overriding, when we call the method, the most concrete method is going to be executed, or the most immediate method is going to be executed, which is the method in our swords class. See a couple of questions, I believe. Will abstract method be on the midterm? I believe so. I'm not exactly sure. I believe everything up until last week is on the midterm. I would double check with the notes that Dr. Raval has on D2L. What would sword equal new weapon do? Try that out. I believe it would cause everything to crash. Comment everything out here, just so we're only working with this one method. This is going to crash because the variable that we have here should be more general than the type we have declared here should be more general than the type we have here. So we say that a sword is an instance of weapon, but a weapon is not an instance of sword. So logically speaking, every sword is a weapon, but not every weapon is a sword. That's one way of thinking about it. And just to double check that I'm not wrong, I'm going to try compiling it. And once again, we get a syntax error saying a weapon cannot be converted to sword on line 32. And this is line 32. Do one that takes block into effect. You the method from superclass that you can. If you want the method from a superclass, you can typecast it to our superclass. So we can actually try that. So let's try a bit of typecasting. Okay, so what I'm going to do is declare a weapon. And cast a sword into that weapon, into object, and then do my weapon that do damage. So it compiles, and we get do damage for 19, which is actually the method right here. And that's actually opposite of what I was thinking. I was thinking that if you do the typecasting, it would call the appropriate method, which would be down in the weapons class. We explain why weapon sword equals. Okay. So re-explain why this doesn't work. It's because the type declared here no, actually this works because every sword is an instance of type weapon. The part which didn't work was sword W equals new weapon. This doesn't work because the sword is not more general than the weapon. So we can say that every sword is a weapon, but not every weapon is a sword. So like you can have maces, staves, morning stars. You can have other types of weapons. So that's why this would fail. This. So yes, there we go. Axis. Yeah. So typecasting here is still calling the most concrete method, which is the one in our swords class, even though we are typecasting it to from a sword. Try it this way. Parentheses. Not sure if I'm allowed to do this, but let's try it anyways. And I can. So even typecasting it down here, it still calls the method in sword.java. The superclasses is the general version of a class, and the children's classes are like add-ons to the parent class. So the first part there is correct. So the superclasses are general version of a class. The child classes are the more concrete version So with our sword weapon example, we also have, let's say, a vehicle, and then we could have cars, buses, planes, trains, other automobiles. Still typecasting a weapon to weapon. Okay. Let's go from most concrete to most generic. Yes, plane, trains, and automobiles. I'm glad you got the reference. I tried that joke a few years ago in the same CPSC 233 tutorial. No one got it. Yeah. Fortunately, typecasting still calls the method for swords.java. They are more specific version of a parent class. Yes, child classes are more specific versions of parent classes. Okay. These are good questions. Do you have any more questions regarding our overloading, overriding? Or should I move on to polymorphism? How could I give answers to these type of questions on the midterm? Unfortunately, I cannot answer these questions on the midterm. That would be up to your knowledge. If they are, I can mostly answer technical difficulties questions. So if you're having to misunderstanding something, I can clarify that. But I don't think, now don't quote me on this, but I don't think the midterm is going to be this specific. What values are set to the object weapon sword equals new sword? Let's try that. Comment out all these. Well, we know it's a weapon type, so we can do the name. Compile it, run it, get the name, Jason Lee. Where is our... That's odd. Oh, there we go. So we just have these tracing print statement right here. We have name Jason Lee, damage 19, which is the one we described here. What happened if the sword class was made abstract? If the sword class was made abstract, well, that would give us a few errors because the parent class weapon is not abstract. And we won't be able to instantiate an instance of sword. We would need something, a child class of sword, which would need to be a more concrete class. If we declare that our weapons class abstract, we can never do weapon W equals new weapon. Well, the second part of this line always has to be a more concrete class. All right, guys, can you please stay on topic a bit? Because if I'm correct, the stream is showing the chat as well. I'm not sure how well, but and it's also hiding some of the questions that are coming. Thank you. No worries. Speaking of which, just 1 second. Just because somebody mentioned them. There we go. We have these right here, all 7 of them. What does it mean by concrete? So a concrete class is a class that you can instantiate. So our sword class here is concrete because you can do something like this. You can do, create an object of type sword. Our weapon class here, you can't do it because it's an abstract class. So it needs a more specific version of it. So in our case, let's say sword. So if you actually try to do weapon w equals new weapon, this will give us an error here. So weapon is abstract, it cannot be instantiated. The higher you go up in the hierarchy, the more abstract you get. That's a great way of phrasing it. Yes, that's true. When you did your getting, you needed to set it to return.dis.damage to refer to the parameter, right? Yeah, so when I did return this.damage, I'm referring to the instance variable damage, which is declared up here. I guess more specific would be this line. We have this.damage, and then we just have the word damage, DMG. This.damage refers to the instance variable here. However, this particular one, without the word this, refers to the argument. It refers to a more local variable. Yes, creating a class abstract means you can't instantiate it. You need a child class which will extend this particular class, and you can instantiate that. And I just realized it looks a bit strange watching the stream that I'm looking to my right. That's because where the chat's open here. I'm sure you guys already assumed that. I know the camera is up here. All right, so let's move on. Sure, people have things to do. Since we're already talking about abstractions and inheritance, what's the purpose of having an abstract parent class? What's the purpose? The purpose is to make sure that nobody can instantiate something too generic. So let's say if I'm creating an RPG game, and I don't want there to be a generic weapon. I always want it to be classified as something, a sword. We went over the list earlier. If I want to ensure that no one can have a generic weapon, they need to have a more specific type. That's where I can have an abstract class, and I can ensure the behavior of these more specific child classes by declaring abstract methods. So if I were to make sure that every instance of weapon, so every child of weapon has a do damage method, and they all behave a bit differently, I can declare this as a abstract method. So comment this out. public abstract void do damage. Now what this says is every child of weapon should have the method do damage with this particular signature, without the word abstract, of course. And it should have some kind of method body. So every type of weapon would be able to, you can call the do damage method. Questions, abstract class methods are not defined. They're meant to be overridden. Why is the point of declaring them in the first place? So first of all, not every abstract class method is undefined. A lot of times they are defined. So when we had the do damage method, it was already defined. What's the purpose of having abstract methods? That's, as I mentioned just a few seconds ago, is to ensure that every child class has that particular method, and it implements it in its own way. So maybe swords behave differently than staffs, and axes and maces, etc. Yeah, and you can definitely expect what behavior to, dictate what behavior to expect from a certain class. Earlier, it seems like it's impossible of a subclass of weapon to access do damage method. Parent class, that's true. So from these examples, yes, it is impossible for a subclass of a weapon, or rather our sword class, to access the do damage weapon here. But let's say if I were to create another class for staffs, and that one did not have the do damage method, it would access the one in the parent class, which is the one in our weapons class. So the example here is, if we have a generic type weapon, it has a generic do damage method. But if you have a more specific type weapon, so in our case sword, it can do a more specific type of method. So just to actually show that, so like we can actually create a new class, public class, get a staff. So what do staff have? Let's say private string magic type. So default constructor, that would be magic type. Let's just say a generic staff, or a default staff is a fire magic. It does 14 damage and is called something. I'll let you guys pick a name for it. Big stick. That's what I'm going with. Thank you, most basic. Somebody asked for the name Papa. So since that one was an earlier request, I'm going to overwrite it here. Okay. So this brings us into polymorphism, because what we can do is public void, and you guys can guess, do damage. Zen's blessing. That's a nice name. Okay. So we have our staff class. It has two constructors. I'm just skipping the copy constructor because we don't need it anymore. We've done the copy constructor examples. It has its own do damage method. Now we can go back to our driver. Now we can actually create a staff. Now, to actually show you guys, if this wasn't the case, that this method actually existed in this class, so we have the do damage method actually part of our weapon class, and then when I do staff.doDamage, it is going to call this particular method because there's nothing of this type down here. It's just been commented out. Show you. I do. Oh. Parentheses. Oh, yikes. I may have the ordering backwards. Int string. What did I do wrong here? Oh, weapon cannot be instantiated. You get rid of this. Cannot find symbol staff.doDMG. And that's because I got to extend it. What else? Everything else seems fine. Compile. The reason I'm compiling and running the sword class is because Java compiles the files as needed. And the driver is in our swords class, the main method. So as we see that the weapon does damage for 14. That's the method being called. Okay, I think I have a few questions here. Okay, so the difference between weapon sword equals new sword and sword equals new sword. So let's see. Difference between here and let's say call it sword 1. What's the difference between these two things? The difference here is that when you actually have referencing this particular variable, so just sword, you can assume it to be of type weapon. So you can assume that it can do everything that a weapon can, which is all the methods in this class. Sword may be able to do more things, but we can assume that it can just do these things. And ideally, we don't care about all the extra methods that our sword.java has. We only care about the methods that our weapon class has. But instead here, for sword 1, we do care about the extra methods that the sword class has. But we're saying specifically this is a sword. The sword, so they both, sword 1 does inherit from the weapon class. So sword 1 can do everything a sword can, which is everything, all the method it has in itself, as well as the method it inherits from the weapon class. But just this one can only do anything a weapon can, not specifically what a sword can. And this is what's called abstraction, because we're taking away a bit of the detail. We don't care what kind of weapon it is, all we care that it's a weapon. what's the point of weapon sword? So what's the point of for creating something as a generic sword? That would be in case you don't, depending on what your project is, what you're trying to do. If you are okay with having just a very, very generic weapon which has no actual extra abilities, you can have a very generic weapon. So that way you can have weapon W equals new weapon. But if you do need these objects to have more specific capabilities and they differ in certain cases, then you can have an extended sword class. Yes, in our case, you can't instantiate a weapon class because it's declared abstract. But you can have a reference of type weapon. So another way to see this is internally, the system knows that it's a sword type object. But as a programmer, you only see it as a weapon type object. Does the first line only work in sword.java? I'm not sure what you mean by first line. If you tried that call in weapon, that would be an error because of constructor. So the reason I'm calling these lines here is because the main method is located in sword.java. I can move everything to weapon.java and it'll behave the same. Okay, so would weapon, or sword be better programming-wise? And that's a great question, and that really depends on what you're trying to do. It depends on which method that you need to access and what instance variables you need to access here. If you do need the specific capabilities of the sword class, then the latter is better. So then the sword is better. But if you don't need the specific capabilities of your sword class and you only need the capabilities of a generic weapon, then you can do the weapon type reference, which is the former. So I think an example here would be okay. So we have a method in our sword class called a sword specific method, but it has no reference in the weapon class. Okay, and then now let's say we have these two objects. I'm gonna comment out this one. I should have chosen a better name. Very long name. We have sword and sword 1. They're both of type sword, but the reference for sword is weapon, and the reference for sword 1 is sword. I'm saying that word so much, it's starting to look like S word. All right, let's compile. Now, why do we get this particular syntax error or compilation error? It says it cannot find the symbol sword specific method. And that's looking at this one. The reference of this variable is of type weapon. it knows only what the weapon class knows. That's it. If you go for a more concrete methods, so let's say the do damage method, and there is a more concrete version of it, then it goes for the more concrete version. Because internally, the system knows that it's a stored object. However, for this instance, for this local variable, sword1, even the reference is of type sword. So this reference, or this reference, knows about everything this particular class can do. And that's why it can call this method. So if I were to comment this out, compile it, where'd you go? There we go. It is able to call it. I'm hoping this clarifies the difference between references and types and why abstraction is a handy tool. It's related to what information you need from the object. If you need the most concrete type, so if you need the weapon to be of type sword because you need the sword specific method, then your reference should be of type sword. But if you don't need those specific methods, then you can have a more general reference of type weapon. I'm hoping that makes sense. Neat. Got one, yep. Can weapon sword access the methods in weapon class prevent overriding the weapon method? So when we do this one, it cannot prevent overriding the methods. It will use the overriding method. So it'll use the most specific methods, which is this one right here. And that's because internally the system knows, the Java virtual machine knows, that this is a sword type object. The one thing we have to distinguish is there's the reference of type weapon and the actual information stored in the system that's of type sword. So when you call the method do damage, it's going to call the most specific method. And that's the purpose of overriding. If you need to be able to call both methods depending on what you're doing, then either you have a design flaw or you need to you're trying to do something else, or your inner method should be able to call these super methods. If I were to do something like this, everything else commented out. Compile that. There we go. Weapon does damage for 19, do damage for 19. If you want to be able to call the method in the parent class, you can do something like this. Or if I want to do something else, I can do, I'll public void do damage. Now here we are bringing in overloading, or Boolean call parent. If you really want a choice to be able to call, distinguish between the two and choose which one you want to call, you can do something like this. You overload the method with a different parameter, which you can use as a flag to know which one to call. And if you have multiple types, or if you have multiple layers in the hierarchy, use something more than a Boolean, like an integer, and use it as a flag. If a call parent equals 1, do something. If it equals 2, do something else. If it equals 3, do something else, and so on. And weapon sword equals new sword access the methods in weapon class. Oh, that's the question I was just answering. So this is one way to call the method in the parent class. You're welcome. Right. Going back. Polymorphism. Already very much related to what we're doing here. So we created our other class called staff. We showed that it has a method for do damage. I'm just going to comment out a bunch of this code so that we're not having a lot of print statements. Also going to comment out these tracing ones. I'm only commenting these out so that when I post them, you guys still have access to these and you can play around with them. Okay. So we have weapon does damage for 14, and that's because in our main method we create a new object of type staff. Then we do staff.doDamage. Staff itself does not have a do damage method because it's been commented out, so it calls the method right here. Where'd it go? Right here. But if I were to do this, then we fall into the same thing we've been discussing this whole time, and that is it's going to call the more concrete method. You shall not pass. Now the fun part begins is when we actually have better names, W1 and weapon W2. Now we have something like this. So we have two different weapons. Internally, one is a staff, the other one is a sword. And then we call the do damage method on both of them. Now, both of these methods have the same signature, right? And both of these classes inherit from our weapons class. What I'm going to do is, since we've already talked about the more concrete stuff, so we both have we have two weapons, weapon 1, weapon 2. One is a staff, the other one is a sword. Both of these classes inherit from the weapon class. The weapon class has an abstract method called do damage, and the sword and staff both instantiate that method, or rather implement that method. Now, as a caller, from this perspective, I don't know what kind of don't know what these objects are. Internally, I don't know, I don't care. All I know is that they're both weapons, and they have the method called do damage. So, we compile, we run, and we get from the staff we get you shall not pass, and then from the sword we get do damage for 19. The system knows internally which objects it's referring to or which particular classes it's referring to. And as a developer, from this perspective, we don't care. Now, this becomes really handy when you're working with other people's code. You can actually treat them as what's called black boxes, because you don't care what's happening on the inside. All you care is the values being returned to you, and if you pass in something, it behaves as the way you expect it to. And this actually brought me back to something I just thought of. I'm going to change the name here. Frostborn, and that is a pretty good analogy of reindeer, but I would say it's more like a reindeer is an animal, but an elephant is also an animal, and they all make sounds. Okay? So if it's an animal, we know that it makes some kind of noise, but a reindeer would make a different noise than an elephant. So that's where polymorphism comes from. If we just have a generic animal, somebody gives me a box and they say that there's an animal inside. It's Schrodinger. Hopefully there's some air holes and food in it, and it's not being tortured. But somebody gives me a box and it's like, okay, there's some animal in it, and I'm going, okay, what do I know about animals? They can make noise. So I would, have it make some kind of noise. And depending on what kind of animal it is, it would make a different kind of noise. But the only purpose that I needed is to make some kind of noise. It's like breaking things into subcategories. Yes. No matter if you declare an object as a parent class, the side. So this is where we're getting a bit confused with terminology. This here is the reference type. So when you're creating, this is a reference type or the variable name. The W1 is a variable name, or rather it's a variable, and its type is weapon. When we do this, this is actually instantiating an object. So the type of the object is staff, but the type of the variable, reference type, reference being another word for variable, is called weapon. All right. Okay, so we're having a question about the weekly exercise. So yes, it's the weekly exercise for tomorrow and Thursday tutorial is kind of like a quiz, but not really. It's a quiz in a sense that it's not a coding exercise. You're asked to do a few questions, which are similar to what you've been doing in class. So this is method tracing or method call tracing. I couldn't find a good way to do this coding wise, because then it's just simple coding and you're not really doing any kind of tracing. So I had to create it as a quiz. Now I could have asked you to do a hard copy and submit it manually, but I don't want to mark over 250 assignments manually. D2L allows us to mark it automatically. That's why, but you have to declare it as a quiz. However, it's worth exactly the same marks as any of the individual exercises. Definition of polymorphism exactly. If I were to read definition, see what I can get. Polymorphism is the ability of an object to take many forms, which is what follows the term from the polymorph. Because we have a weapon type object or weapon type reference, it can take many forms. Here, it can be a staff or a sword. Using our animal example, it could be a reindeer or an elephant. But it's still an animal. Yes, when we have this kind of thing, they normally change behavior from the parent class. They normally have a bit more information by means of having more instance variables. They might have method overloading, overriding kind of things. But they can still do everything the parent class can. So we do have to move on because we are getting a bit late. Privacy leaks, that was the next topic. And instead of actually doing coding much, I would do more for here. Or actually, I can actually do it this way. So this is similar to one of the examples we've done in the past. So we have public class location. So basic location class with X and Y coordinates. We have public class shape. It has a location, has a name. Or rather, we don't even need a name for this. Okay. Okay, so you have a question about interface. I would like to come back to that after we're done the main part, because I don't think we've covered interfaces in the course, so I can come back to that later. Two ways of preventing privacy leaks: returning primitive types or new objects. Those are two ways, yes. So, trying to make sense of what Zen said. Which part? I've been saying a lot of things for an hour and a half now. Much of arrays? I'm not sure. As I mentioned in the email, I haven't seen the exam yet. I don't even know the format. But if you want, we can add it to our list here. You can ask Dr. Raval as well. Okay. Although I believe she's quite busy this week with demos. Okay. So, what location? So we have two classes: a location, which is just an x and y coordinate; a shape, which consists of a location, essentially. And the constructor, which takes in a location object and it just assigns this reference, the instance variable, to whatever's passed in, and the get log just returns the same object. Okay, so I believe when we were doing the example here, we had an example like this. Just so we don't get confusion with the variable name. So I'm just going to call it lock1, new location. X would be I really hate a thinking number, so that's why I love just using a D20 and just roll it, because these are just examples. What I'm going to do is public string toString method for this. Which will just print the location of the shape. Are arrays of primitives susceptible to privacy leaks? Yes, they are. And I can cover that afterwards, or in this example. It's not, privacy leaks are not only related to return types, they're also related to other things, which I'm showing you right now, which is where we are passing in objects. So in this example, we create a location type object called lock1, and when we're creating the shape object called myShape, we pass in lock1 as a reference. And if we see here, this just assigns to whatever is passed in, this log.equals lock. Now, if I were to print system.out.println shape, I want to print my shape, and then I'm going to change the coordinates in lock1. $17, and I'm gonna need a set x value. Okay. and then I'm going to print my shape again. What we want to happen is when we create the shape, we want the coordinates to be 9 and 8 for its location. And when we print it here, we want it to print 9 and 8. However, when we change lock 1, we only want to change lock 1. We don't want to change anything within the shape. So when we print out my shape again, the values we wanted to print, we want it to be 9 and 8 again. We don't want either of the x value to change to 17. Command prompt. But that's not what's happening. What's happening is when we change lock 1, set x, we're actually changing the location in my shape as well. And the reason this is happening is because of the following. Let's see. Drawing on here is going to be fun. So let's see. Okay. So we have a shape here. I'm going to call it. It's lock 1, or rather, it's a location type. And we know location has two instance variables, x and y. So initially the x is equal to 9, and y is equal to 8, if I recall. Yes. So let's say this is saved in computer memory when we actually do this line. When we do this, this object is created in memory. Okay. And what it does is it so this is our reference. Lock 1. Arrow. Here we go. Get properties for shape, width, and just change the color. Okay. So what's happening here is we have this object in memory of type location with these values x and y, and then we have a reference lock 1, which is referencing this object in memory. Yeah, so this is what's happening is if you update lock 1, shape, the location in shape is also being updated, which is what we don't want. And then when we actually create our shape 1 object, so let's do this. When we create our shape object, it has a reference to a location object, because if you recall here, it has a reference to a location object. And what is actually happening here is it's referencing the same object. And that's because when we do this, when we pass in lock 1, we're passing in this reference, which is just this pointer to this object in the system. So it's the memory location of wherever this object is stored. And then we assign the same thing. So this lock equals whatever this is. So the lock instance variable is also pointing to this object. Now when we say lock.setX. So we go towards a lock. It's pointing to a location, and then we say set x to 17. Do we notice what happens here is that our shape, oh, I forgot to mention one thing. So this is also, we have a reference to this. It's called shape 1, I believe, my shape. So when we actually update using lock1.setX to 17, well, we have my shape, which is referring to a shape object, which is referring to the same location object. So the location of my shape also gets changes. And that's not what we want. What we actually want is when we pass in this reference right here, we want it to create a new location type object. Something like this. Initially it's 9 and 8, so turning back to 9. And you wanted to point to something like this. Now, what we can do is when we can do lock.setX to 17, this doesn't change this at all because this remains what it originally was. And that's preventing a privacy leak. Now, how do we do this in code? You can do this simply, this.lock equals new location. And then when we compile, run, it does not change the location for my shape. Second thing is we can do location mylock equals my shape dot get lock. Then we can do mylock dot set x to 4. And then print my shape again. What we want is to be able to get a reference or get the location object that's stored in my shape, change it around. But what we don't want it to do is when we make this change, we don't want to change the location in my shape because we only want to change this my lock, not the one in my shape. But if we compile, run, well, then that changes the x value here. Because a similar concept is happening here. We get a reference my lock, and it does the same thing that the same problem we were having before, which is it's pointing to the same object. And that's why when we go from mylock.setX to 4, whoops, it changes the location of my shape. Now, in order to prevent this, we do the similar thing again. Instead of simply, well, I'm just going to copy this here. That makes things easier to see. I want to do the same thing. I want to make a copy of this. And point my lock to that one. So this was originally 9. It was 9. And then when I change this to 4, when I do mylock.set x to 4, now it changes to 4 here, but the location here, the x remains as 9. And then when we fix this, same thing as before. We create a new instance of it. Here we go, that it does not change. All right, so that was privacy leaks. Genzi seems confused. Is there anything I can clarify? Do we have any questions regarding these privacy leaks? I will move on to privacy leaks with arrays right after. Hello? Are people still here? Either things got really confusing or too simple. So we don't seem to have any questions regarding this. Okay, getting on to arrays. So let's just do something fairly simple. I'm just going to comment all this out. Arrays are used for storing a series of objects. And the way they work is we declare its type. So let's say we want to have an array of type strings. We have square brackets. We give it a name. String array. New string. And then in here we declare its size. So we want to know the size of how many things we will be storing. Let's say I'm going to give it a 5. I'm not really rolling a d20 for this because if there's 20 of them, that'll just make things really confusing. So 5 is a nice and small number. And then we can do str, right? We can reference them. So always starting at 0, a 4. I don't think I can answer that question, at least not on here. So we have an array of length 5, which consists of 5 different strings. And now let's say if I have another method, call it array method. I realize this is not a great name, but just trying to work things fast. Array. Let's go 3 equals So here we have an array, a string array of type length 5. Originally, we instantiated with values A, B, C, D, and E, so 5 strings. We print them out just to check. Now we call this array method where we pass in a reference to str array. Which what it does, it goes into the third index and it changes the content. And then we print our array again. I want to see is just changing the reference in here, my array here, does it affect our original str array? Let's take a look. Oh, got the return type. Okay. And here we have evidence that it in fact does change the content of the array. Because originally we got printed A, B, C, D, and E. But next we got print A, B, C, hello world. This is the change we made. And then E. So how would you handle this as a privacy leak? Same thing we did before. Create a new instance of the array. Copy the contents over. So it would be string. Call it new array. We want to make sure it's the same length as our original array. And we have a for loop. Yeah, we do. Count less than So what's happening here is we create a new array, and when we call our array method, we pass in the new array after we've copied over all the content. File, run, and now we have evidence that it does not change our original array. And that's essentially arrays in a nutshell. Thank you. All right. Now, do we have any other questions regarding privacy leaks and arrays? Where was the privacy leak? So when we, see if I have that here. So originally, we didn't copy our array, our original array, which was str array, and we just pass it in directly here, which changed the contents of our array. You know, it made index 3 into the string hello world. And so when we printed it again, we got the privacy leak being here. It was the third index was changed to hello world. But when we fixed the privacy leak by creating a new array, copying all the same content, so they're both identical, and then passing in the new array, when we print it again, we don't get the change. Yes, we have to treat arrays as another object. Because it is object-oriented programming that we're working with. Okay. You're almost done. Method call tracing. You're welcome. If I recall, someone asked me to do like a blocking method on here. Let's just do that. So let's say we have, going back to our sword example, our weapons. So we have public, let's say void. We don't really care about return statements because we're just doing simple testing. Block. So the idea behind this method is we have this other weapon trying to attack us. We don't care what kind of weapon it is. It's just a weapon, so we know it has the do damage function or do damage method, and it has an instance variable of type int called damage. It has the get damage method, and what this block is going to do is it's going to reduce the damage that we're taking. How much is it going to reduce? Let's say it's going to reduce it by half. Okay. So the way we do this is so we get the damage of this other weapon. Or rather, it's divided by 2, rounded down, because int doesn't do decimal places. Okay. So now if we go back to our code down here, so we have weapon 1 of type staff, weapon 2. We want to have a specific class sword, so we want to be more specific here, because a generic weapon cannot do the block method. We know a sword can, only a sword can. So we have to change the reference of W2 from weapon to sword. So move these. What we can do is W2.block W1. We compile our sword class, run it, and then we end up the resulting damage being 7, where the original damage would have been 14. So we can actually print this. Sure to compile and then run. So the original damage we see is 14, and the resulting damage blocking by half is 7. Similarly, polymorphism, we're connecting topics here. So let's say this one can also block. Public void block. Let's say the staff is a bit different. Now this may not make sense, but for argument's sake, let's say the staff blocks all damage. Why? I don't know, it just does. So we do, see, Eggs. Pass me that thing. Big thing. Okay. No. Put it here. Okay. So yes, a staff blocks all damage. So now, once again, we can do. We would have to update the reference type here to staff, and w1.block w2, compile, run, and then using polymorphism we get the different methods being executed. Okay, now we actually want to go with the method call trace. So we're going to bring back our nice printing messages. So system.out.println, call this sword.block weapon. And here. And then in our weapons class, we can bring back some of them. Let's say the get damage. What else? Get name. We want to get rid of the ones that are for the constructors, because that's really throwing me off. Okay. Yes, I noticed you, OBN. So we're working with our call trace. What we do here is w2.block. We know w2 is of type sword. So right away we jump into this particular method because we've gone over this several times now, that the most concrete method gets called, the most immediate method gets called. So we do this, jump into this method, so we end up printing sword.block weapon, which is here. Next, we follow along. We have this other.getDamage. And what this means is other is of type weapon. But internally, we know that it's of type, this other is of type staff. Okay. So it goes in the staff class and it tries to find the get damage method, but it doesn't exist here. So it goes up here and it finds the get damage method right here, and it prints out get damage. Next, this get damage method does its thing. It does this print out here. It returns this, so the code jumps back to this line and it assigns the value to new DMG. It does this print out here, and it does this print out here, and then it ends the method call trace right there. Now, when we do the second one, the one thing I'm going to do is I'm just going to add. I'm just going to add a break in there. so that we can distinguish things more easily. Okay. The first one is the same as before, except there's an end trace here, which we put it in our main method. The second one is w1.block w2. w1 we know is of type staff, so it goes to the staff class. It does the block method, so it does its print statement right here, staff.block print here. It goes to this other class, which is other.getDamage. Internally, the system knows that this other class is of type sword because we did w2, and w2 is of type sword. So it goes and tries to find the getDamage method here because that's the one we are looking for, getDamage. Tries to find it. It cannot. So it goes up to the parent class, which is weapon, and then it does the getDamage method here. It does its printout statement, and then it returns. And then the rest of the method continues. Just to make things more clarified, so let's say we add the getDamage method here. I'm going to add it here. Public int damage. So I'm overriding the method, but it's just going to call the super. So here we see a bit of a difference here. Is when we have our staff, the getDamage weapon, when we do other.getDamage, we don't directly jump to weapon. We first jump to sword.java, and this method now actually has the getDamage method. So it prints this line, system.getDamage, which is right, or rather sword.getDamage, which is down here, which in turn calls super.getDamage, which is right here, which prints out this line, just get damage here. And then this returns, it returns to the sword class, which in turn returns to the staff, which in turn does the remaining of its own method. And there we have a method call trace using polymorphism, traction or inheritance, and that's the example that I could think of. Now, do we have any other questions? I haven't read chat in a while. You're welcome. Do we have any questions, comments at this point? Aldo saying thank you. You're welcome. Explaining super real quick. So super refers to the parent class. So when we do in our sword class, when we do super.getDamage, we don't want to call this method. If we just do getDamage, it'll call this method because it has the same name and same signature. So it'll call this over and over and over again, and it'll just run into an infinite loop until the system crashes. We want to do super because we want to tell the system to look into the parent class. So it'll look into the parent class of weapon, and it'll do the getDamage method here. That's what super is, looking into the parent class. Yes, you can have arrays of any type, ints, doubles, a generic object that or new object that you created. So we can have an array of swords, array of weapons, array of staffs, array of locations, array of shapes, any class that you can come up with. A difference between array and array lists is that arrays, you have a very static or very strict structure. So you have to declare the size of it beforehand, rather here. Array list, you don't necessarily need to define the size of it beforehand, and you can keep adding and removing stuff easily. And if you want to just go into deeper, I believe array lists internally have arrays which you don't see, and then they keep changing their sizes based on what you need. So here we have, I believe that covers everything. I didn't go into GUIs, mainly because it's a very generic topic. I would need to actually prep for it in advance to do this, because I'm terrible at GUIs. And I don't think I had any questions regarding that. Oh yeah, someone mentioned mages and polymorph. Unfortunately, I don't have my Frostmourne here. It's at my other house, but I do have my Doomhammer. I just like showing off this thing. It's heavy. A Doomhammer is not a sword, of course. Warhammer. I cannot bring this to university to campus. Might get arrested. So I don't think we're getting any more questions. Are abstract classes going to be on the midterm? I believe so. I'm not exactly sure. I believe it's everything up until the Friday class last week. All right, you're welcome. Yeah, thanks guys for joining in. I'm having a request to stream some Borderlands 2. Unfortunately, I have to get some of my own work done and try to relax a bit before coming to class tomorrow. I am not going to buy Mass Effect. I haven't even played Mass Effect 3 yet. It's just sitting in my library. Normally, I wait for games to get down to, well, significantly cheaper than the original price before I buy them. A grad student cannot afford brand new games. We can talk about the gaming and streaming another time. Let's. Yeah, thank you guys for coming. Thank you for all the follows. I don't think I have the notification set up, but no, I got a few follows earlier. We appreciate it. Yes, so this stream would be available right, after it ends, it's available right on my channel. I'll post a copy of it on YouTube as well. I'll upload this code on D2L so that you guys can also play around with the code and the examples. All right. Yes, that's everything. Now, unfortunately, I do have to call it a night. Thank you all for joining in. And once again, thank you for all the follows. Hopefully you guys enjoyed this and it was beneficial. It will help you study for the midterm. So this has been Zan from Zan's Gaming and Java Games Programming, signing out.